So this problem, we're going to redraw the circuit to make it easier to calculate. So I can see here, this is the positive side of the battery. So I'm going to draw that over here. So this is the positive side, and then I'm going to go around this way. So I can see if I go around this way, I've got everything. So this line is connected to the battery, this line is connected to the battery, this line is connected to the battery, and this line right here is connected to the battery. So all of those lines are connected. So I can say, okay, let's go this way first. So I've got C1, and C1 comes all the way around and back down. So it looks like I'm going to have to the battery 1, 2, 3, 4 lines off of here. So let's do this. 1 line, 2 lines, 3 lines, 4 lines. And we're going to make this one C1. And the next one, this one's going to be C2 and C3. So one here, make one here. The next one we'll do is C4. And the last one, come out of here, and C5. So all of these, then if you notice, C1 goes back to the negative side of the battery. C2 and C3, right, after them, they go back to the negative side of the battery. C4 goes back to the negative side of the battery, and C5 goes back to the negative side of the battery. So we can draw this like this. And then we can put in our numbers. So this is 10 volts. This is C1, and C1 is 1 microfarad. I'm just going to put 1, not add the units. C2 and C3, they're in series, so it doesn't matter the order. So this one's a 2, and they're both the same. So this one's a 2. C3 is, or C4, this is C4. And C4 is 4. And then C5 is 5. Okay, so the first thing I'm doing is calculating the equivalent capacitance. So one thing I know is that in parallel, the capacitance in parallel adds. And the capacitance in series is 1 over C equivalent equals 1 over C so let's say the only one we need to worry about here is 2 and 3. They're in series. So 1 over C2 plus 1 over C3. And that's what we're going to actually do first. We're going to put these two, we're going to redraw this, and we're going to combine these. So we're going to have this, and we're going to have C1, which is 1. We're going to have C2 and 3. We're going to have C3, which is 4. And we're going to have C5, which is 5. And this is, we're going to draw this one. This is just the equivalent of 2 and 3. All right, so what does this equal? Well, if we use this equation, we're going to have 1 over C equivalent. Just for these two, I'm adding these two, and I have to add them this way using this equation. So 1 over 2 plus 1 over 2 is equal to 2 over 2, or 1. So C equivalent, when I flip it, it's just equal to 1. So this just becomes 1. Okay, and so now I can make this into just one capacitor, right? Just by adding them all, they all add in parallel. So I can just say 1 plus 1 plus 4 plus 5. So that's going to be 1 plus 1 is 2, plus 4 is 6, plus 5 is 11. So this is going to be 11 microfarads, and this is going to be 10 volts. So here my equivalent capacitance is 11 microfarads. Next is find the charge on each capacitor and the voltage across each capacitor. So the charge, if we look at the total charge, right, we can figure out the total charge because we know that Q, so this is going to be, I'll put B here. So Q total, well, I know the equation is just C times V. So I can multiply 11 microfarads times 10 volts, and I get 110 microcoulombs. So that's the total. But now what about each one? Well, I can use the same equation, CV, right? And so it's easy to do 1, 4, and 5. So let's just do Q1 is equal to, if I plug in C, I'm going to get 1 microfarad times 10 is going to be 10 microfarads, or 10 microcoulombs. That's Q1. Q2 is going to equal C, or so let's not do 2, let's do 4. We'll save 2 and 3 to do the hardest. That's the hardest one, not hard, but we'll just save that. Q4 is going to be 4 times 10, which is 40 microcoulombs. Q5 is going to be C for 5 is 5 times 10, so that's equal to 50 microcoulombs. And now if I think about these two, I know the capacitance has to be, the charge has to be the same on both, and that's because this part of the capacitor and this part of this capacitor are connected. So the total, I'm going to use this capacitance to figure out Q2 is going to equal Q3, and that's true for capacitors in series, and so that's going to be equal to, we're going to use the 1 microfarad times 10 volts is equal to 10 microcoulombs, and that's true for each. Okay, so now if we think about, let's see, we need to find the voltage across each capacitor. So if I look here, let's just look at this one for a minute. So the voltage is 10 volts. So I have 10 volts here, and 0 volts here, because that my battery, the 10 volt side is connected to each one of these, and the 0 volt side is connected to each one of these. So I've got 10 volts across here, 10 volts across here, 10 volts across here, and 10 volts across here. So that means I know that the voltage of 1 is going to equal 10 volts. The voltage of, that's equal to the voltage across V4, and the voltage across V5. And now looking at this, right, I know the voltage here is 10 volts, the voltage here is 0 volts, and these two capacitors are equal. So they're going to split the voltage. So V2 is going to equal V3, and that's going to equal 5 volts each. And I could also, if I wasn't sure about that, I could also say, well, I know what Q is. Q is equal to 10 microcoulombs, and each of these is equal to 2 microfarads. And so I can say, well, the voltage then is just Q over, so where's my equation? Right here. Voltage is just Q over C. So I could calculate it that way also. And now, let's see, part D. So part C, so let's see if I can write C, part C over here. What is find the energy storage in each capacitor. Where did I do that? So I can say the energy storage U is equal to 1/2 CV, and so I know that, let's see, right, here we go. So let's just do U1 is going to be 1/2 times 1, because it's 1 microfarad, times 10 volts. And this should be squared, by the way. Where did I have that? Oh, there it is. Okay, so this should be squared. So this is going to be squared. This is a 10. So U1 is going to be, where's my notes? Oh, there we go. 50 microjoules. And you can figure out the math on that. So I've got 1/2 times 1, so that gives me the 5, or a half. And a half times 100 gives me 50. And so 50 times 10 to the minus 6 gives me 50 microjoules. And then U2 I'm going to do the same way, right? I'm going to plug it in. I'm going to have a half times 2 times 100, because it's 10 squared. And I'm going to have, now that's going to equal 100 microjoules. And that's going to be true for 2 and 3. So this is also equal to U3. So these are equal. And then U4 I'm going to do the same way, right? So I'm going to get, for U4, I'm going to get 200 microjoules. And for 5, I'm going to get 500 microjoules. And then if we place the 6th capacitor in there, I'm going to do D on another video, because that just might take